So let's talk about more of the deep sea. One of the first things I want to talk about is just why we don't know that much about it. So for those of you who don't know, 95% of our ocean has not been discovered yet, which means we only know about 5% of it. That's not very much. And there's a few different reasons for why this is. The first reason is that it gets dark really, really fast in the ocean. There's places where there is no sunlight at all. And the second and almost more important reason of why humans cannot be in the deep sea and why it's so hard to study is that as temperature goes down, pressure goes up. So put out your guys', give me some thumbs up, 2 thumbs up. So we're gonna say as pressure goes up, temperature goes down. So temp down, pressure up. And a good way to describe this is, have you guys ever been to a pool or been in the ocean and have tried to dive down and your ears hurt a little bit? That's because the temperature is going down, but the pressure is going up. So you're getting pressure on your ears because of this whole thing. So the deeper you go, there's actually some parts of the ocean where the pressure is about 1,000 times greater than what it is on land. So here's another picture of this little superhero who's carrying this car over his head. Now, we obviously can't carry cars, we're not strong enough, but that's how it would feel in the deep ocean, is if you almost had a car on your back. And that's nearly impossible, and as that's happening, the water's also going to freezing temperatures. So these are 2 reasons why it's just really, really hard to get to the bottom of the ocean and why we haven't explored it that much. So let's go over some worksheets before we keep going. And now I filled this one in a little bit for some extra stuff, but if you guys remember Dora's lesson on oceanography and there was this worksheet, it has like your zones up here and your depth zones on this side. Now, like I said, don't worry about everything else that's covered in. We're going to go over that in a little bit. But definitely get this worksheet out. And then also, there are these 2 pages as well of some different animals. So get this one out as well. Like I said, we're not going to be doing one and then the other. We're going to kind of work with these worksheets interchangeably. So just make sure that you have them both out. And also make sure that you have a pencil, a pen, a marker, anything that you can write with. And if you want to go a little farther and more detail, then get like a few different colors out. Okay, so since we have started all of these lessons, we have talked a ton about animals that are in the sunlight zone. So if you remember this worksheet, you guys can see up here, I know it's backwards, unfortunately it's on my phone, so it's just the way it's going to be. But on the sunlight zone right here, that is anything from the top of the ocean all the way down to about 650 feet or so. And the sunlight zone, there's tons of sun, so there's tons of life, and actually about 90% of all animals that live in the ocean are found in the sunlight zone. So today we're going to be talking about the zones and the animals that live everywhere after the sunlight zone, and just why they're so different and why they're not really like a lot of the fish and animals that are in that zone. So I have a few more questions for you guys, and get that worksheet out because we're going to start adding to it. I'm going to ask you a question. I want you to try and take your best guess in the comments, and then that question is going to help us determine what things we need to label on this sheet. So my first question for you guys is, where do you think the deep sea starts? So what makes the ocean the deep sea? Do you think it starts at 200 meters below sea level, 300 meters below sea level, or 400 meters below sea level? Where do you think the deep sea starts? And if you are looking at that Ocean Zones worksheet, take a look about what you have and what you did with Miss Dora, because it might give you some hints and it might help you guess a little bit. So the deep sea starts, you can see this, right after the sunlight zone ends. So if you guys want to take a marker or a pencil, highlight that line and you can write deep sea right there. deep sea starts, you still do have a little bit of sunlight, but just not a lot. So the twilight zone has some sunlight, but just not as much as the actual sunlight zone does. So that's going to be your first line that you wrote right there, that deep sea. My second poll question is, where does light completely stop? Does it completely stop at 200 meters, 1,000 meters, or 2,000 meters? Where do you guys think light completely stops, where it cannot reach? 200 meters, 1,000 meters, or 2,000 meters? Again, looking at this ocean zones worksheet might help you guys a little bit. So, on here, so this is our deep sea line. This next line, where it says 1,000 meters, so right after the twilight zone, this is where light is completely not there anymore. So sunlight cannot reach any ocean depths past 1,000 meters. So you can write that, another line right there, and then write no light. Cool. All right, my last question for you guys, and one of the last things that we're gonna mark on the page for now, is where is the deepest part of the ocean? So I'll give you a hint, it's definitely in that Hadal zone, but where is the deepest part of the ocean? Do you think it's where Mariana's Trench is? Do you think it's off the coast of Florida? Or do you think it's where the Titanic wreck is? So do you think it's Mariana's Trench, off the coast of Florida, or where the Titanic sunk and where it is now currently at the bottom of the ocean? All right, so good job everyone. This answer is the Mariana's Trench. So this trench, the very bottom of it, is where we, at least scientists think now, is the deepest part of the ocean. They think it's about 10,994 meters below sea level, which is very, very, very deep, where there's almost little to no life at all. There's almost no oxygen, and it's freezing, freezing temperatures. So I want to do another little bit of a review with you guys. So I have another question for you. Do you think Mariana's Trench, is it made by the plate boundary that's a convergent boundary or a divergent boundary? So is Mariana's Trench, was it made from a convergent boundary or a divergent boundary? So remember, all of our world is made from plate tectonics, and when these plates move and shift, they create like earthquakes and volcanoes and trenches. And so which one created Mariana's Trench, a divergent or convergent boundary? All right, so this one is a convergent boundary. So everyone put up your hands just like this. Now we can remember that divergent boundaries shift away from each other, while convergent boundaries kind of shift inward together. So one is going to be going under the other plate. And so when that happens, that's how a trench is created, just like the Mariana's Trench. So now that we talked a little bit more about what zones create the deep sea, now I want to talk to you more about how animals actually are able to live there. Because like I said, low oxygen, low temperatures, it's super, super dark. So these types of animals need different characteristics and adaptations in order for them to survive. So let's talk about some of the adaptations these animals have. The first one I want to talk about is that a lot of these animals have really big teeth, really big eyes, and really big mouths. And this is because, think about it for a second, if it's pitch black out, and you cannot see because there's no sunlight there, and the only light that you can get, you need to be able to hunt and to live, you're gonna really want huge eyes. So here is a picture of a viperfish. So these guys live really, really deep down in the ocean, about 1,000 meters down. And you can see it has huge eyes, but not only huge eyes, it has huge teeth, just like so. And like I said, huge eyes because they need to suck up any light they possibly can, but they have huge teeth and mouths and they keep them open a lot because that gives them a better chance of being able to find and eat prey. So that right there is a viperfish. All right, so the next one we're going to talk about is the giant squid. So let's find a picture of a giant squid. Let's see here. All right, so here's a picture of a giant squid. I think this is a cartoon picture, but it's fine. So this guy adapts to the deep sea environment because it is red. So a lot of animals that are in the deep sea are either red, black, or completely transparent, which means that you can see through them. And this is because those colors are hardest to see in the deep sea. Those colors, obviously, black and transparent, blend in with the dark background. But actually, a lot of animals are red as well because red is very hard to see in these environments too. So the giant squid sees this red guy right here. So one of his adaptations is that he's red, like I said. And another thing that's interesting about a lot of deep sea animals is that they're way bigger than their shallow counterparts. So a normal squid or a normal gastropod like our octopus, those types of things, they're going to be much, much smaller, where deep sea animals are going to be much, much larger. Another adaptation that we have is that a lot of these animals are carnivores. So a carnivore is an example of an animal that only eats meat. So I have another question for you guys, so answer it in the comments. Why do you think that animals in the deep sea are only carnivores? Do you think it's because they just really like meat? Do you think it's because all plants are toxic in the deep sea? Or do you think it's because there's no sunlight? So do you think it's because they really like meat and they don't like plants? Do you think it's because plants are toxic in deep waters? Or do you think it's because there's no sunlight? So I'll give you guys a few seconds for that one. A few more seconds. All right, guys, so good job. This answer is because there is no sunlight in the deep sea. So think about this for a second. If there's no sunlight, then that means that plants have nothing to eat. We know that plants photosynthesize, which is where they take energy from the sun and transfer it into food and sugar for them to live. And so if there's no sun, then there's definitely no plants. And so all these fish aren't going to have plants to eat. So that's why they're all carnivores, because there's no plants there. There's no sunlight. So it's their only choice, really. So that's another interesting adaptation. Another adaptation is that a lot of animals that live in the deep sea, so remember I said pressure is really, really high. It's 1,000 times higher than it is up above sea level. So a lot of these animals, they have like organs, and their lungs or gills and their bodies are very easily compressionable, which means that they can kind of mold to whatever pressure is in the water. So this right here is a leatherback sea turtle. And this guy, he doesn't have a normal carapace or a normal shell like his other turtle species friends have. His carapace is made out of something that feels very similar to leather, and he's actually a very oily animal. And all that does is make it much easier for this leatherback to be able to dive down to really, really deep depths. A leatherback can actually go about 3,000 feet or 1,000 meters below sea level, and its body that's easily compressed helps this animal do it. All right, so the last adaptation that I want to talk about is something that this guy does right here. So as you know, this is an anglerfish, and this is from Finding Nemo. And something that this anglerfish does is use bioluminescence to help it see in the water. So I'm going to show you an example of what bioluminescence is. Obviously, like I said, there's no sunlight in the deep sea. And instead of sunlight, animals take chemicals, and there's a chemical reaction that creates light for them called bioluminescence. So this is a glow stick right here, and there's not very much light where I am right now. Yeah, let's see, I'm trying to get a little bit darker. And even though there's no sunlight in here, this glow stick, once I crack it, all of a sudden can completely light up. So you guys, I'm sure, have all played with glow sticks before. They're super cool, and it's just a crack and chemicals mixing together, and all of a sudden light forms. So just like how this glow stick made a chemical reaction to create light and to glow, this is what fish do as well, and it's called bioluminescence. Tons of animals do it, not only in the deep sea, but you can actually see bioluminescence on the top of and surface of the water as well. Jellies do it, fish do it in the deep sea, some octopus and squid do it, and so it's just a really cool phenomenon that happens that helps these animals live and to see. And this helps with them finding their way around and to eat prey and to navigate. So it's a very important and very awesome thing that happens. All right, so that is some of the adaptations that some of our fish have. And now I want to more explain some of the activities I have today. So this right here is called adapting to the deep. And there's a few different species that live in the deep sea on it. And in each box, it has some components of different adaptations that I just talked about. So bioluminescence, the body is black, red, or transparent. Maybe it has thick skeletons or thick scales, big eyes, really long lives. So that's another thing that I didn't mention. But some of these fish can live up to like 200 years because of how slow moving they are. That's just another example of an adaptation from the deep sea. There's also compressible lungs, gills, and organs, so just like that leatherback sea turtle. And then finally, big teeth. So you're gonna look at each animal, and this is what I was saying, if you're not sure what these are, Google might be a really good resource, or the website that I posted on our blog, because it'll help you identify some of these crazy creatures, and then you can have a better idea of what they look like and their characteristics, and it might help you fill this worksheet out. But we can do the first few together if you would like. So the first one is the headless chickenfish. So that's that sea cucumber that I was talking about. And this guy, he can go to a max depth of 2,969 meters. So you guys can write that down. So 2,969 meters. So right where it says max depth, you guys can put that on there. All right, some other things about this headless chickenfish is that its body is completely transparent. So that's why you can kind of see that tube-like structure inside of it. So you can cross off the body is black, red, or transparent. And also it's very, very flexible and has like a very squishy outer body. And this helps it adapt to really deep pressure. So it also has compressible lungs, gills, and organs. All right, the next one. This is the Cuvier's beaked whale. This is the whale that can go the deepest out of all other whales and dolphins. So this guy can go to a max depth of 3,113 meters. And some things that help this guy out is that it has also that compressible body. So its body is very well adapted to big, deep pressure and to those really cold temperatures. All right, let's go on. So this is a Japanese spider crab. I know that in this picture you can't tell how big it is, but these guys can get huge, huge, huge. Let me try and find a picture one while we're working on this. All right. So let's see here. So here's someone holding one of these crabs. That's how big they are. So they're really, really big. So for this one, you can cross off large size. They live really long lives. They can live up to about 100 years. They're very, very tough. So they have a very thick exoskeleton. And also their body is red. So again, remember that red bodies is very good for dark places because it's the one color that blends in the most besides just being completely black. All right, this is a barrel-eye fish. Barrel-eye fish are amazing creatures because most of their body is sort of dark or black, but their head and their eyes are completely transparent, which means you can actually see some of the organs inside of this fish. Now their max depth, how far deep they can go, is 2,315 meters, and they have a ton of different adaptations that make them unique to the deep sea. So they use bioluminescence, so that just like this glow stick right here, they can use a chemical to react to create light. Their body is transparent, and they have huge, huge eyes. Definitely look up a picture of a barrel-eye fish if you can. I can do it right now for you as well. Just so I can show you just how big their eyes are. Let's see, here's a good picture. So that's a front view, and their eyes are huge. They are used, like I said, those big eyes to take in light and almost act as like a magnifying glass in order to see their prey. All right, the next fish is called a chimera. These guys are a little bit spooky looking as well. They're also nicknamed the ghost fish, and they almost look like they have different puzzle pieces for scales, and that's kind of why they're called the ghost fish. They almost look like a little bit of a zombie. These guys, their max depth is about 2,606 meters, and their body is super dark colored. They have really big eyes, and these guys can live extremely long lives. Scientists actually aren't even sure how long they can live. They don't have a good way to track them. As we know, only 5% of the ocean has been discovered, so it's really hard to be able to study these creatures that are so deep below the surface, and we just don't know that much about them. All right, finally, the cookie cutter shark. These guys are pretty small sharks. They live at a depth of 3,413 meters below sea level. And these guys, they're most known for their jaws. So they're called the cookie cutter shark because their jaws look like a perfect cookie cutter. Let me show you a picture of one. So this is a cookie cutter shark jaw. When it's completely open, it'll bite you in a complete perfect circle. So this fish was bit by a cookie cutter shark. As you can see, it's like perfect lines. So that's what they're most known for. And these guys, they live extremely long lives as well. And also their skin and scales are very, very loose. So they can also manage pressure really well. So they have compressible lungs, gills, and organs as well. So that's the first page for here. If you guys want to go ahead and do the second page on your own time, that would be totally awesome. The answers are online, so if you need help guessing, like I said, Google them. It's a great way to figure out more about what these species are, and then you can figure out that second page with my answers and just by guessing by yourself. Okay, so the last thing I want to do with you guys today is go over a few more species. And I have an at-home activity you can do if you really like arts and crafts and if you like drawing, because it'll be really, really cool, especially if you like doing those things for a long time. So back to Miss Dora's Ocean Zones page. So this is that page right here. Remember, we marked deep sea, the no light, we marked Mariana's Trench. Well, I also think it would be really cool if you guys place some of the animals we talked about or do your own research and find animals that you really like and place them on this ocean zone chart. So for mine so far, I've colored in a human. So the world record for a human scuba diving is 332 meters. So this guy's in the twilight zone right there. There's still a little bit of light where he is, so I placed him right there. I also placed the wreck of the Titanic. So the Titanic was found at 3,840 meters, which is right in that abyssal zone, right there. And then finally, Marianas Trench. We're going to talk about this at the very end, but there was, the deepest part of that is called the Challenger Deep, and there was a submarine a few years back in 2012 that almost reached the bottom of Marianas Trench. So that submarine was also called the Challenger Deep. So I put my submarine right here. On the blog, I put it up earlier this morning, but I have some extra pictures if you guys want to use the things that I put on my map, and we'll go over some of them here. So here are some more of my pictures. And yeah, these guys all live at different places in the deep sea. So the first one is the oarfish. The oarfish is the longest bony fish in the entire world. And this guy is at about 600 meters. So you can kind of buy that human right there. So I put my oarfish there. I have my anglerfish. This guy has that little bioluminescent light. It has those big teeth. And he is at about 900 meters. So kind of a little bit lower than my oarfish. Put it right there. And as you guys are doing this on your own time, feel free to color them in, tape them down, cut them a little bit nicer than I did. The next one is the leatherback sea turtle, and he is at about 1,000 meters. So I can put my guy kind of like right next to the oarfish or the anglerfish. The next one I have is called chitin. So this guy's a little bit weird looking. This is a type of mollusk, and it's called the deep sea chitin, and it's one of the deepest animals in the entire world. It can sit at about 6,917 meters, which is right here by the end of that abyssal zone. So I'm going to place my chitin right here. So now I want to talk to you guys a little bit more about the at-home activity that you can do if you are interested. So over here, I printed out, or I put on the blog for you guys, a few different instructions and a few different pieces of paper to print out. And this will be really easy and helpful if you finish that ocean zones activity first, and then you start to work on this next activity. So you need 3 to 5 pieces of printer paper. We're gonna make a deep sea animal ocean poster you can hang it up in your room or something cool like that to remind you of how deep and interesting these animals are. And you're basically going to take that worksheet, that ocean zones worksheet, and stretch it out to make it really long. So I started mine right here. Mine I did 3 pieces of paper. And you're almost just gonna create your own chart just like Miss Dora showed you and put in your own animals. So I started mine at the sunlight zone. I got basically to the twilight zone and I'll finish mine later. But I have a manatee and an orca at the top. I put my Japanese spider crab at about 300 meters. We have my scuba diver, my leatherback sea turtle, and a narwhal, which actually can go about 2,000 meters below sea level. And you guys can get creative as you want. Maybe if you want to color in the complete background to show the lighter zones from the darker zones, you can do that. If you want to research on your own different animals that you can find in the midnight and abyssal and hadal zones, go ahead and do that. But then start drawing them in, because it's much easier to visualize, to see all these comparisons, than just to think about it in your head. So that's a really cool art project. I'm going to finish mine and I will post a picture of it when I'm done. But yeah, like I said, I have a few worksheets online that you can use if you want to use some of my animals that I decided I wanted to do, or you can go online and choose animals that you really like, that you think are really cool, maybe something different that we talked about today, or an animal on that adaptation sheet. And then definitely take pictures of them so I can see them when you're done, because I love an art and craft activity, and so I want to see what you guys come up with. Okay, so lastly before I go, I did want to talk to you guys about one more thing. So like I said, only 95% of the ocean, or 95% of the ocean has not been discovered at all yet, which means 5% has. And there's a few notable people that have actually been to the deepest parts of the ocean that are pretty cool. So I have a poll question for you guys. This might be a little bit hard if you don't know these explorers' names, but who do you think has been to the deepest part of the ocean? Do you think it was explorer James Cameron, or do you think it was the explorer Victor Vescovo? Victor Vescovo or James Cameron? So you can write that name in the comments. For those of you who do know a little bit about the deep sea already, you might have heard of the name James Cameron before. In 2012, he was that guy who took the Challenger Deep to the deepest part of the ocean, which was Marianas Trench. He didn't make it quite all the way there, but he traveled about 35,700 feet below sea level. And it was in that submarine. It's so crazy to think about because, like I said, all that crazy pressure that builds up when you get deeper and deeper in the water. If he had like one little slip up, if maybe something went wrong with his submarine, all that pressure would have crashed on him instantly, and that just would be so crazy and scary. So all these explorers and scientists are so brave. So he was the one who had the record for the deepest part of the ocean for a very long time. But last year in 2019, explorer Victor Vescovo actually beat his depth by like 1,000 feet. So James Cameron went about 35,700 feet, and Victor Vescovo went 35,850 feet. So not by very much, but he is the new person to have the record for the deepest dive, which is pretty cool as well. So that is all I have for you today.